Scale drawings are really, really neat. Basically, it's just a proportion. They're very simple. They look very, very confusing, but they're very simple because it's just a proportion. Don't overthink it. All right, so scale drawing, it's proportional, it's two-dimensional, and it's a drawing, so it's like a map. A map is a great example of a scale drawing. Scale model is proportional and it's three-dimensional. So a good example would be like a model car or a model airplane. All right, so the scale is the ratio of our drawing or our model to our actual. That's what your scale is. The thing is with ratios, order matters. With proportions, order matters. So you're always going to have your drawing or your model on the top, and then your actual on the bottom. If you're writing it this way, you'll always have your drawing or your model first, and then your actual second. All right, this map, I had to blow it up, so this is no longer proportional. But what it is we are trying to find the distance from Cadillac to Detroit on this map. And it says 1 centimeter, I don't know if you can see this, I'm going to write it a little bit bigger, 1 centimeter over 50 miles equals 3.5 centimeters over d miles, and we are solving for d. So I know that I can do my cross products here. 50 times 3.5 is 175. And then here we have d times 1, so that is just d. All right, so 175 miles, make sure you label it, you have to give it meaning, is the distance from here to here. You can use a map to find the actual distance. This is a really good example too. It says the Earth's core is 2,300 kilometers thick, and we're trying to find out what we should use for the thickness of our scale. Our scale is 1 inch to 500 kilometers, so we can use that and solve for how thick our model should be. This one is a little bit different. Make sure you don't mix up scale and scale factor. Scale is your ratio. It will always be labeled. Scale factor is when you don't label it because both the actual and the model or the drawing are in the same measurements. So they're both in inches, or they're both in feet, or they're both in centimeters. So we are going to try to find the scale factor of this model. It says 10 inches to 100 feet, but I can convert that down. I can reduce that down to 1 inch. If I divide by 10, 10 divided by 10 is 1, and 100 divided by 10 is 10. So I can reduce that down to 1 inch over 10 feet. And I know that there's 12 inches in every foot. So I know that my scale is going to be 1, because I'm not changing my inches, I'm going to change my feet. 10 times 12, there's 12 inches in a foot, so 10 times 12 is 120. I've got to write that so you can read it. 120. So our scale factor is 1 to 120. Our scale is 10 inches to 100 feet, or 1 inch to 10 feet, but our scale factor is all in inches, and I can just write 1 to 120.